Good morning. Today we are reviewing for our test. So first we are going to look at order of operations. Remember, when we follow the order of operations, we are doing PEMDAS, multiplication and division from left to right, and addition and subtraction from left to right. So first, we don't have parentheses or exponents in this first problem over here, but we do have multiplication and division. We are not going to do multiplication first. We're going to do whichever comes first as you read from left to right. And as I come across division first, so we need to do that first. 12 divided by 4 is 3. So we have 20 minus 3 times 2. And then we're still on multiplication and division. We have multiplication. So 3 times 2 is 6. So 20 minus 6 should give us 14. And that's our answer. On this next one, same thing. Let's do parentheses first. If we have more than one set, we start on the inside. 9 minus 5 is 4, and that's squared there. So then 4 squared is really 4 two times. 4 times 4 is 16. Inside here, still doing our parentheses, 20 minus 16 is 4. And last, we just have 8 times 4, which is 32. Here's another one, but we need to evaluate because we're missing a couple numbers. I made a mistake. This should really be 25 and not just 5. So here we have negative 3. It's touching the square root here, so that's multiplied by the square root of x, and x I changed to 25 because I made a mistake, remember? And then it says minus 7. On the bottom, these are touching. This really means multiply. X is 25 times y, which is negative 2. So square root of 25 is really just 5, because 5 times 5 is 25. So we have negative 3 times 5 is negative 15, and then minus 7. So negative 15 minus 7, they're all negatives. So add them up, that should give us a negative 22. And then 25 times negative 2 is going to be a negative. 25 times 2 is 50. We know that 2 negatives here would make a positive, and we can simplify 22 over 50. I can divide them both by 2, and we'd get 11 over 25. I would accept that as an answer. If you converted that to a decimal, that's fine too. Number 2, it says you're buying mangoes that cost $1.25 each, but you only have $6 to spend. Number 1 says make a table. So we're going to make an XY table. X, if we're not sure, look at your chart here. X is going to be our number of mangoes. Well, we can buy mangoes. We don't know how many. We could buy 0 mangoes. We have $6. So we'd have, it says here, amount left. So it's not that we spent $0, it's that we have $6 left. So 0 mangoes would cost $6. 1 mango, it would cost $6. We have $6 in our pocket. Is going to cost us $1.25. So subtract $1.25 from 6, and you would get $4.75 left over. Remember, y is how much money you have left. If we buy 2 mangoes, another mango, we're going to subtract another $1, so we're down to $3, and subtract 25 cents, we're down to 50 cents, $3.50. A third mango, subtract another $1, we're down to $2, and another 25 cents, we're down to $2.25. Another mango, 4 mangoes, subtract another $1, we're down to $1, and subtract 25, just $1 exactly. But I don't have enough money to buy another mango because it costs $1.25. So this is as big as my table can go. So then let's graph this. At 0 mangoes right here, we would have $6 left. At 1 mango, we bought 1 mango, $4.75 left, somewhere about there. Then 2 mangoes, we have $3.50 left. 3 mangoes, $2.25. And then 4 mangoes, we'd have $1 left. So it says write an equation for the function. Remember, our equation, look for our x's, they go by ones. Our y's, we're really going down each time by $1.25. So that's what we're doing over and over and over. So that goes with our x, 1.25x. And then look for 0. We have $6 to begin with. Look for 0, whatever y is what's added or subtracted. Here's one very similar to that on your test. This next one says make a table for the function, identify the range, and graph it. So here they already told us what to plug in for x. We're going to plug that in here, and it's touching, so that's multiply. So first we're going to plug in a 2. 1/2 times 2, and then add 3. Well, half of 2 is 1, so 1 plus 3 is 4. Then 1/2 times 4, because we're plugging in a 4 right here, and then plus 3. Half of 4 is 2. 2 plus 3 is 5. Then we're going to do half of 6. Half of 6 is 3 plus 3 more is 6. And then plugging in an 8, half of 8 is 4. Plus 3 more is 7. Some of you see the pattern 4, 5, 6, 7. Next should be 8. These numbers, it says identify the range first. Our range is what we get out our y values, so just list them: 4, 5, 6, 7, and 8. And then we need to graph these. This is our x-axis, this is our y-axis. So x is 2, 1, 2 to the right, y is 4, up 1, 2, 3, 4. Then 4, 5, if you want to list that as 4, 5, you can. 4 to the right on our x-axis, and up 1, 2, 3, 4, 5. Then 6, 6. 6 to the right, up 6. 8 to the right, up 7. And lastly, 10 to the right, up 8. There we go, we've graphed our function. Next it says write a rule for the function. First, we need to make sure our x's go by ones. 1, 2, 3, 4. Good. Second, find your pattern. Our pattern, we're going up by 3 each time. So that goes with our x. Y equals 3x. And then look for 0. There's no 0. We need to work backwards. Instead of adding 3, we're going to subtract 3. 1 minus 3 is -2, so it's subtract 2. Next one. Again, make sure your x's go by ones. 0, 1, 4. Uh-oh, we need a 2 and a 3 in between here. For a 5, 6. And you guys, we really only need to figure the pattern out just a little bit. We don't even care about these numbers down here. Going by ones here, our pattern 2 to 3 would be add 1. From 3 to 6, there's 3 numbers in between here, and we have to put 2 in between there as well. It would make sense to put a 4 and a 5, that way they each go up by 1. So again here, this would be plus 1, plus 1. Our pattern is plus 1, 1x. And then look for where there's a 0, this one is plus 2, because it's a positive 2. Then we have this down here, it says, is it a function? Remember, looking at our pop machine, we need to look that all of our inputs, our x's, are different. Here we have 2, 5, 8, 6, 5, 4. Well, we have 2 times that we pushed the button 5 on our pop machine. One time we got out a 4, and the other time we got out a 1. So no, this is not a function, because there's more than one output. More than one output for the number 5. There we go. This is where people got a little bit tricked up. Classifying and ordering real numbers. Tell whether each number in the list is a real number, a rational number, an irrational number, an integer, or a whole number. Then order the numbers from least to greatest. So I'm going to make a table or a chart here. We've used these in the past. I'm going to put my numbers across the side here. Negative square root of 12, negative 3.7, square root of 9, and 2.9. And then across the top, I'm going to write the types of numbers: real, rational, irrational, integer, in whole. So remember, our real numbers are really all of our numbers. We don't have fake numbers, they're all real. Then we have rational or irrational, or they can't be both. Irrational numbers are just pi and square roots that are not perfect squares. Remember, our perfect squares are like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. These are our perfect squares. They would go on and on, looking at your multiplication table as well. So any, like, square root of 10, well, 10 is not on this list, so square root of 10 would be irrational. So square root of 12, or negative square root of 12, 12 is not on that list, so that is an irrational number. If I were to plug that in my calculator, it would go on and on. Negative 3.7, that's not one of these two, so it must be a rational number. Any fraction or any decimal, any counting number, they're all rational numbers. Square root of 9, well, that's on here. The square root of 9 would really just be 3, because 3 times 3 is 9. So that's a nice, normal, rational number. And then 2.9, that's a decimal, that's fine. Alright, then our integers, these are negative or positive counting numbers that you'd see on your number line. The only ones that I would see on my number line here is really the number 3, because I don't count by decimals or by square roots when I count by ones. And then our whole numbers are 0 and just the positive counting numbers. So 3 is also a positive counting number, that's a whole number. None of the rest of these are counting by ones. Oops, I forgot we got to put them in order. We know, starting with the least, the number that's the least will always be the biggest negative number. We don't know what square root of 12 is, but I know it's between the square root of 9 and the square root of 16. So the square root of 9 and the square root of 16. Square root of 9 is really just 3, so remember these are negative, so negative 3 and negative 4, because this is square root of 16 is 4. The square root of 12 is right between 12 and 16, so it's around like 3.5 something, maybe a little bit less, because it's only 3 numbers from 9 to 12 and 4 numbers from 12 to 16, so it's a little bit less than 3.5. So 3.7 is actually the biggest negative number, because negative square root of 12 is really only like negative 3.5 or 3.4. Then our positive numbers, the least is 2.9, and then our greatest is 3. Alright, it says wall poster. You are considering buying a square wall poster that has an area, keyword there, of 6.25 square feet. Find the side length of the wall poster. So here's a square. The area on the inside is 6.25. We need to find one of the sides. We don't know what they are, so I'm going to say that's x. However, area is base times height, and since it's a square, we know both sides are the same. So x times x should give us 6.25. Well, another way to write x times x, like 3 times 3 is the same as 3 squared, x times x is the same as x squared. So to get rid of this square, the opposite of a square is the square root. So we're going to take the square root on both sides. That leaves us with just x. And the square root of 6.25, in your calculator, you have to push the second button, the yellow one, and then the x squared button above that is the square root. So it'll put a square root like this in your calculator, and you have to type in 6.25 and push enter, and you should get about exactly 2.5. So one of the sides is 6.25. Alright. The U.S. Department of Transportation determines the sizes of the traffic control signs that you see along the roadways. Cool, but we don't really need that information. The square, okay, they tell us it's a square. Square Pennsylvania State Route sign at the right has an area, again on the inside, of 1,296 square feet, or square inches. Find the side length of the sign, same as before. If we know one of these sides is x, we know x times x equals x squared, or 1,296. So if we take the square root of 1,296 to undo that square, again, just type it in your calculator, you should get exactly 36. So one of these sides here is 36. So if they asked you to find the perimeter or the length around the outside, you would have to add this up 4 times or multiply it by 4. Another words for perimeter would be like around or fence, things like that. Area words would be like if you're going to paint the whole wall, it would be the whole area of the wall. Or if you're going to mow the lawn, the whole area of the lawn. Or fill in. Words like that would be words for area. So quick review of distributing. If you have a big set of parentheses here, we know to distribute or draw a box. On front we have a 6, and then we have negative 2x plus 5. So 6 times negative 2 is negative 12, and there's an x. 6 times 5 is 30. So we have negative 12, that's a 12, x plus 30. Over here, this one, we know to draw a box as well. On the top we have 8 plus 3x. There's really not a number here. You cannot make this a negative 12. You cannot do that. This is really a negative 1 that's multiplied. The 12 we'll just have to add on to the end. So negative 1 times 8 is negative 8. Negative 1 times 3x is negative 3x. And then we have this 12 here as well. So combining our like terms, 12 minus 8 should give us 4. So our answer is 4 minus 3x, or negative 3x plus 4, either way. Last one, we're going to distribute, draw our box. In front, our teacher is a negative a or a negative 1a. It's touching because we know it's multiplied. And then a minus 5 on the top. This 6a we're just going to have to add down here at the end as well. So negative 1a times 1a is negative 1, and a times a is a to the power of 2. Negative 1a times negative 5 is a positive 5a. So we have negative 1a squared plus 5a plus 6a. We can combine our like terms. The only like terms we have are 5a and 6a. This has a squared, it's not the same. So our answer is negative 1a squared. And then 5a plus 6a is 11a. That's our answer. Alright, if you have questions, please make sure you ask. Otherwise, good luck in your test.